On this episode of the show, I have with me CJ King. He is CTO at Torc, and we're going to be talking about scaling trucks. Well, we're going to be talking about massive scaling of trucks, and we're going to ask CJ what that means, and we're going to talk about how he is approaching this problem of trying to get 10,000 plus trucks mindset, maybe more, onto the market, and how that is something that you need to start looking at early versus trying to think about scaling a little bit differently than maybe others have. And we'll talk a little bit about society's acceptance, some of the rules and regulations at the trucking industry, and I'm sure a whole other stuff in there. CJ, thanks for taking the time.
Thanks for having me on. Pretty excited about the conversation.
Absolutely. Before we start, just to make sure everyone knows what we're talking about here, what does the company do?
That's great. So Torc Robotics, we actually build an autonomous truck. It's a Class 8 truck and the entire stack, and that is a semi-truck. So everything you see on the road that's moving, all of the freight, all of the things we want to get next day delivered and all that, from large facilities, hubs that we call them, to other large facilities, other hubs. So hub to hub trucking, long distance, long travel, and really the over the road that gets us from a point, say in Texas, all the way to a point in Ann Arbor where I'm at, bringing all that through there. So how do we get all the distributed goods to us, and what do we focus on? Really bringing a safer, faster, more reliable solution to the road of trucking.
Absolutely. I love this topic. I think it's going to be interesting for the audience to hear this discussion, and maybe we'll actually dive in talking about what the goal is, because I know you mentioned, obviously I had the luxury of speaking to you and understanding some of what your thoughts are around this model, and it's not about can we just build one autonomous truck. That is one thing you could do, but that's not something you're thinking. Help us understand that.
So yeah, a lot of autonomous folks like, can I make something autonomous? There's a bunch of AI and a bunch of ML. Can I go do this thing automated with a computer? And yes, there's a lot of things we can do, but really to be impactful and to kind of change the industry, it's not can I build one, it's can I build 10,000? Can I build 1 million? How do I take the steps to set us up to really scale, to support, because there's so many millions of vehicles on the road every day. And we take that for granted that the US, our first market, is a large market. And there's so many trucks moving goods everywhere to cover all the 300 plus million folks that live in the US and get us everything. So it's really, how do we start? How do we get to tens of thousands first and then millions of trucks second? Not can I get one? Because one doesn't really make a dent in moving freight at that level.
Absolutely. I guess when we think about this, and I think that's really interesting because there are different approaches and different thoughts of how to create technology, right? Sometimes it is you have to create one. When you go about, and you are trying to obviously modernize, revolutionize trucking, when you go about having that as a goal and initiative, you still need one. I still am assuming you still have to have one that's working before you start making 10,000, because could be wrong. Is there a difference in mindset in terms of how you approach going, all we need to do is get one to prove the concept versus going, I do obviously need to make one that works, but I still need that 10,000, 100,000 to be scalable, doable, functional?
Yeah, so the big difference is, so I think in the market, if you look at it, there are a lot of folks that can show you one vehicle functioning and running. A lot of those are on prototype hardware, prototype software, meaning I say prototype, but there's a ton of knowledge and a ton of expertise that goes into it. And we went through that phase too. How do we make it work on take a big giant computer from the cloud and stick it in the back of the vehicle and make it run? That's great, but that's not something you can do at scale. So we do prove that out. We did all that in our advanced engineering, and we transitioned very early. So we put a focus on how do we actually get to what the product is? What does production intent look like? How do we actually build that from the ground up? So that means from the rubber to the roof, we have an entire stack that's built to be able to be on a Cascadia, so a Freightliner Cascadia. It's a fully redundant chassis. It's a fully redundant drivetrain. It has our stack, which puts in a fully redundant compute platform, which is the brains of the operation, and a fully redundant multimodal sensor suite that allows us to have all that built out. And we're doing that in our production intent. And why do we do that? Because it makes it and changes some of the problem statements. So I can't just write a large neural net that runs on something in the cloud that I just keep adding computers onto. I have restricted limits of how I can distribute my compute, how I actually have to pull in the sensors, how I have to communicate between the stack and allow data from one camera to get merged with other cameras, to get merged with LiDAR, with radar. And when you do that in a limited function on the embedded stack, which is what you need to be able to say it's robust and safe and secure, which is what all automotive ECUs are right now. We started all the way at the beginning, and we started that journey at the beginning of last year. So we're 18 months into that journey already, putting it on real hardware, on real embedded stack, so we can actually prove that we're safe and prove that we're robust and reliable to everything that's coming down that you see in the real world.
Absolutely. I guess if we wanted to maybe frame this, because I know when it comes to consumer cars, we hear a lot more about autonomous vehicles. We've heard about one company trying with the truck, all right, and that's fine. We'll leave that there. If you are comparing this to what most people understand when it comes to, and maybe people seen the Waymos on the street, a lot of the thought of advantages to seeing some of them driving around some cities. If you were looking at the problems they're looking to solve and the problem you're looking to solve with a truck, because I'm just as a layperson thinking cargo, huge vehicle, turning challenges. I mean, I see some of these truck drivers. I think they've got to be one of the best drivers on earth to do what they do and safely. What are, and I guess from a technical standpoint, maybe when you're looking at this from a technology standpoint, what do you have to worry about that a company that's working on just the car version of autonomous vehicle does not?
Yeah, the way you phrased it, it's a very large vehicle with a lot of cargo, which means it's a bigger vehicle. It weighs more. It takes longer to slow down because it weighs more. Those are basic physics functions, right? So if I'm large and I'm moving fast, I take longer to slow down than something smaller. Highway speeds, which is what we're working at. So we're working at the highest end speeds. Our biggest difference are kind of like the key separation of what our algorithms and how we focus is distance. So we need to be able to understand everything starting at 1,000 meters and really fully understanding how do we understand there's cars on the road, we're in the right lane, they're in the left lane, what are they doing? We have to start recognizing them. Just like a human, we kind of sparsely see further out. And then as we get in, we have to like kind of hone in, okay, that vehicle is relevant to me or that tree or whatever it is, and they start being relevant to us as they get closer. We start our process just much further out. So we're starting at 1,000 meters. Whereas in a typical passenger car or robo-taxi world, you're probably starting in the 300-meter range. So it's kind of a little over 3x distance. And that is really important to us to understand because it does take us longer to slow down a 53-foot trailer running at highway speeds. It takes a lot longer to slow that down fully loaded than it does to take a passenger car that's carrying, 2 people, not loads of cargo.
Absolutely. My mind could not help. I won't derail the topic, but a curiosity now. I feel like I have to ask you while you're here. I'm assuming, and correct me in my assumptions, if we're developing trucking that's autonomous, we don't have to deal with some of the limitations of a person driving. That person has to sleep. They need to be rested a certain amount of time. It's a very complex job. They get licensed specially. The impact on the supply chain is interesting to me because we've seen even people try to do drone delivery to reduce time to delivery, but maybe, and if you have to spill the secrets, don't. But out of curiosity, when we look at supply chain and the impact of having a vehicle that can drive further, that can drive more continuously, shrinks the amount of time to get to the destination, that impact on supply chain, it does that move the needle more than maybe other areas that people are trying to modernize within supply chain, just maybe the last mile? So you guys are even a bigger footprint than the last mile. Is that something that you see? Is that something you think about?
100%. So if you think of it, typical driver has an hour of limitations, restriction, how long they can drive, and then how far that allows them to go. That really is something we're looking at. So a typical driver, say 8 hours, we'll just assume in the 8-hour window that can be plus or minus depending on everything else that's going on. But you say a typical driver drives 8 hours, a typical workday, right? Our operational minimum is going to be 20 hours a day. So by that, we're already getting 2.5 times the amount of distance coverage, the amount of time operationally, all of those things. And we can start to actually tailor ours to arrive at more specific times to the different distributions because we can actually program, hey, it's okay to slow down your speed by 10 mile an hour as a human. It's really hard to drive 10 mile an hour slower than you're used to going just to be able to eat up the, delay for 30 minutes so we can make sure that your loading is at all those things come into it. And it really allows the opportunity that we have. The logistics companies are really excited about the opportunity to get longer distance covered in shorter, around the cycle time. So in 20 hours, I can cover 2.5x what a typical route would be, which means I can now go that much further. So I open up lanes and how quickly overnight packages can be delivered and all of that while it's still safer. Because like you said, we don't have any drowsiness in a computer. We don't have any other influences or health or any other restrictions that could impact us as a human. Hey, I had a bad day. My kids kind of drove me crazy and I'm not mentally all there on what I'm doing. That doesn't go into what our system's doing. So by definition, we're going to drive as good and better than a human. And then you remove all the other things that add into where humans degrade, whether it's lack of sleep or, just mental health based on my kids, I just need a break and I need to go out and do something. All of those things add up. And that's why we're going to be safer and deliver the products further distance in shorter time, but very much so in a safer, more secure way.
Hmm. Yeah, I mean, I could just imagine the impact on supply chain alone and how many different parts of the process are skewed towards the human driving a truck a certain amount of distance over a certain amount of days. And then we've also developed air travel of freight and cargo because there was limitations of how far humans. So I actually think this is a very interesting use case of the dominoes falling in other areas. Again, drone delivery to save us that last mile, but that's really not the core of the problem. The core of the problem is most freight, I'm sure you have reference numbers, travels on trucks. And if we could actually speed that up, that means the whole rest of the supply chain, how quickly produce gets to the supermarket, the supermarket can keep it on the shelf a little bit longer because now they have less wastage because it wasn't traveling an extra. I mean, this is to me like just the cascading effect on supply chain.
Yeah, it really is. Like bringing this to logistics and that whole supply chain really is an opportunity to reevaluate our current stance on how everything's done. So you tell me you need to get something from, our Dallas Fort Worth hub up to where I'm at in Ann Arbor. And you're like, okay, that's going to take, I either need to overnight it, which means I'm going to put it on a plane, or it's going to take 3 days because the shifts of a driver to go. Or now with ours, I can do it in a day on a truck and I can do a lot more, I can carry a lot more load than what I would typically do for the same cost in an airline. It changes the whole environment. It does bring it forward. And that's where all of the opportunities we have are really to help that middle long haul mile. The US is just a really large landscape that there's so much area that there's just not the connectivity while it's there. It's just really long. And so like, this is a really kind of a good focal point and why we're so much focused in the US first, because it allows us to cover a lot of those long distances that typically wouldn't be in other regions.
Absolutely. I guess we referenced, some of the rules, regulations in the trucking industry. You're coming along and pretty much tipping over a lot of the core issues of why they are there, right? I mean, I'm sure there's some others that are truck related, but when you think about the current landscape of those regulations, the rules that have to be adhered to, and then you think about your solution, it seems like a bit of a round peg, square hole situation. And also, is there development happening so that they can be shifted to account for the modernization of what you're trying to set out to do?
So that's a really good line of questioning. Like, I think there's a couple of questions there. And yes, 100% regulations and that in a commercial vehicle is different than a passenger vehicle. We didn't have to go do any extra training or any of that out of our driver's license, where in the commercial side you have to, and you got to step through that. But we're actively working very, very closely with regulations. So we have our head of safety, our chief safety officer, Steve Kenner, that's actively working with NHTSA and local governments, meaning the statewide governments inside of Texas and others. We're really focused on how do we bring those rules and regulations to the forefront. So we make sure we're actively working with them. So we host a lot of law enforcement. How are you going to interact with the vehicle? How are you going to get all the documentation? How are we going to do a customs inspection or a vehicle inspection? How do we work it? So we're working actively with all of them, whether it's at the federal and government with NHTSA and others, all the way down into the local governments inside the states, on how do we actually make sure we're going along with them to make it a safer, more secure solution, both for us to move the product, but also for all of our interactions with whether it's law enforcement or some of the folks that are doing the inspections on the vehicle. Is it the right trailer? Does it have the right weight? Has it got all the right tie downs? All the different things that come up through it, because there's a lot more than we would normally think of. As you dive into that world, if you're not from the logistics world, there's a whole lot of things that go into it. And so how do we do that? Is it they pull up a tablet and so they can look through and see all the different communications, checks, verifications. We have a computer that knows more about the vehicle than we can as a human, because we can measure and track everything. So we can provide even more data, more information to any regulatory body or anyone that's involved in actively connecting to it, whether it's at our hub and our partners, whether it's through that. So it's an opportunity to bring more transparency to the process and clarity. And then it also has it to be automated. So you can get a lot more information a lot quicker, because we do have a computer that's passing it all to the cloud, and then we can share it out through that so they can actually get it into their environments sooner, or roadside or at a hub when they're connecting into the vehicles.
Very cool. I guess maybe a question that I'm sure somebody will have, and I guess I'll ask because I have the question. And we have talked about the goal, and obviously to scaling to a meaningful level. I mean, you would impact supply chain, people's lives would be impacted. It's a mission driven goal here. When we think about currently the human doing the driving, and as I mentioned, I have full respect for them. I always try to make sure you never change lane too close. They have a hard job. The hardest thing that you see on the road is somebody who's driving these semis. I mean, when you think about a human doing this, and we talk about AI, we talk about robotics, the immediate question comes out to be is, if it's as good as a human. And I guess when it comes to something like this, which is even bigger in terms of a moving autonomous component, if it's good as a human, how does that fit with what you're doing?
So that's our bare minimum, right? We have to be as good as a human so that we can go out there and talk. And just last week, actually, we announced what we call AB 3.0. And that really brings together how we do our whole autonomous vehicle training and the scaling. And a lot of folks will look at that, and that's great to see the full end-to-end reinforcement learning and how we do introspection and how we have heuristic guardrails. That's all the technical speak on how that AV stack will work and how we prove all that. But as part of that AV 3.0, one of the things is we do real-world simulation-based and generative synthetic data that's all connected and validated together. So for example, we're going to be we already run, 10 million plus miles in real world. That translates to replays in the 800 million plus range for us. And by the time we get to when we're launching in 2027, we'll be running 20 plus billion miles of replay logs, which is all of our So if I see something, we had this instance just down a little while ago when we were in Texas. A lawnmower was driving down the road, just a regular lawnmower that someone was cutting their lawn and decided to take it down the road. And so we had to react to that. But now we'll take that and we'll build out hundreds of scenarios with lawnmowers and other things in different areas so that we can make sure, hey, that was something unique. We wouldn't have normally seen that. We did. Now, how do we extrapolate that? And that really puts us out to generating, 200 plus billion scenarios like that. A lawnmower coming out, or a deer jumping over, or pick any type of thing that you've seen that you thought was odd, and then multiply that out to get us to 200 plus billion scenarios of how do we actually make that safer, train that. And we do that through both real world, but then we use our simulation. So it's full closed loop simulation. It allows us to do full end to end. So we actually do derivation all the way from the beginning, all the way through the end. So we actually can inspect each individual component. That allows us to make sure from the very beginning, we know how whether the camera saw it or a LiDAR point or any of that connects in the fusion and how we bring that forward to our path planning and our predictability and then our motion control, that's all tracked and built out so we can show and prove that, because at the end of the day, you want us to be able to show you and prove to you that it's safer than a human and that it's actually doing everything you would expect it to do. So if we're driving down a road and we need to sway a little bit because all the traffic swaying because there's something in the road, say, it lost cargo. So we have somebody's, throw out a backpack that fell off a truck, that we have to make sure we sway with everyone else so that when they sway into the lane a little bit, we're not, encroaching on them, even though we stay in our lane as the typical rules of the road. But we need to be able to handle those types of scenario and be very human-like in our behaviors so that we get that support and understanding. So as you see more of our vehicles on the road in Texas and in Michigan, where our headquarters are, where our engineering offices are, and our operational center down in Texas, you'll start to see how they behave and how they're operating. And we're doing all this in a very safe and secure way. We have some of the best truck drivers in the world. It's really hard to pass into our actual certification because you take someone, like you said, these truck drivers are amazing. They're the best at what they do. They do things that, most of us could never fathom doing, driving these trucks and handling it. And then we actually go through a bunch of training on how to interact with an autonomous system and how to have reaction time and all that as you're going through it, because it takes a lot of work to be able to say, I can react and handle an autonomous vehicle and have the reaction time when 95 to 98% of the time I'm not doing anything because the robot's perfectly running the truck the exact way that we want it to.
I mean, I think that's going to be fantastic because I mean, obviously the collaboration with the drivers and getting their input into the feedback. I guess when it comes to, we fast forward to 2027 and, your trucks are on the road and they're doing their thing. I guess in this case, when we talk about society, it's not a choice they have to make, right? They're not going to go buy a Cynic car that's being driven autonomously. This is some companies deciding to use an autonomous vehicle for a very great good. That does give you a slight different. It's a bit of an advantage because you don't have to overcome that hurdle. But I would imagine you're still going to get some thoughts, and it's interesting because you guys might be insulated from the views of society in this particular case. Is that something that you guys have to think about? Is it something that comes up on the radar of acceptance, or is it like, hey, people have never really thought about who drives a semi anyways, and should they really worry about this now?
So I would say we always, in any technology, whether it's self-driving or anything else, we need to bring the general public around. Think of what was your first interaction? I don't know what it could have been, but whatever technology first came to you and you're like, oh, now you're like, navigation in a car didn't used to happen. And now it's basically standard. You can plug in your phone, you can bring it in. It's just there and everyone expects that. I remember the days when I had to print out a sheet of paper and I was trying to figure out how to get from, where am I at? I just missed a turn and I don't know where I'm at. I got to ask direction. Like all that stuff changed, but we got adoption because people started to trust the maps to be able to get to their location. So it's no different than that. But it's how do we make sure that we're proving that it's exactly how you want it to be, meaning it's safe, it's secure, and it's robust enough that it handles all of these edge case scenarios. Because 95% of the time, it's just running down a highway between two lanes and it's easy, and that's the easy part, right? Now, as a human, that's where we actually, the distraction, because we're like, oh, nothing's changing, we're driving in a straight line. We start to get bored, but a computer won't get bored. So those are the easy ones. It's all the edge cases. And that's why we talked about so many simulations, so much that. But then we have to actually go in and explain why we believe it's there and how we can show that it's there and start showing those simulations, doing a lot more education of it is safer and here's how it's safer and here's the data. I mean, if you look at it, there's nearly 42,000 deaths annually in the US, and we're actually looking to drive that down. That's just all vehicles related to traffic and safety, right? And we want that to go much lower. And we can be a part of that story, but we have to show and educate and share the information we have. So until you get to see it in action or be in a ride or see somebody share a video of it actually reacting, we were there and someone got to see it reacting to that lawnmower that I mentioned. Wow, it just did exactly what we thought it was. We couldn't have done it better as humans. It slowed down, it tracked it, it saw it, it made sure it waited till it got off the road before it went around it. Like all the things you would expect a human driver to do, our truck's already starting to do all that. And that's how it has to be to prove and to educate how it all connects.
That's really cool. Last question out of curiosity, and if you can't answer it, I fully respect that as well. We started off talking about scaling, and there's a lot of trucks. There's a lot of opportunity to replace trucks. I guess, do you envision we'll see just a slow proliferation of trucks? We'll see a couple here, a couple there, or is there a chance that we'll see hundreds and hundreds once you guys are ready? Because obviously scale is important and market share and all those things are important.
I think we'll see some significant step functions because once it's there, I think the logistics companies are clearly saying this is a super value added and we want it, and we know once it's ready. And it's always once it's ready, we'll take a lot. And so it's once it's ready, I think there'll be some step functions to early adopters. You get over that chasm of the innovator's dilemma, and you get more adoption and kind of follow that whole path. It's going to be those big step functions, but it's not going to be like 5 here or 5 there. That will already be part of pilot groups that they're working with us as we're doing our development in the next year. And then you'll start to see big step functions because we know they want it. We work with them. We have our Torc Autonomous Advisory Council, which is a lot of members from those logistics companies and trucking companies already sit on our board and are on our council that can give us the information and share with us. How do we make sure that we're connecting into their current environment? How are we making sure that we're doing the right things and giving them the right information so they can plug it in day one? Because at the end of the day, it's a hybrid solution. There's going to be human drivers. There's going to be, autonomous trucks, and it's all got to connect in the whole ecosystem because you never go one way or the other if you look at how it works. And so it's going to be there. And that's really, getting into that embedded stack and building that from the very beginning and the production intent. We're building that trust in them already. So that's going to allow us to do our first step function in 27, and then you'll see it very quickly iterate after that.
Very cool. Very cool. CJ, thanks for the time. If someone does have a question, I mean, we try to cover as much as we can in this 30 minutes, but I'm sure we left some things out. What's a good way of asking a follow-up, learning more, etc.?
Yeah, so the easiest way is going to be on torc.ai. That's our website. You'll be able to connect there. It will go to me and a plethora of folks that will be able to answer that. So we have a wonderful marketing and communications team that will help make sure we get all the answers routed. And then just personally connecting to me or reaching out on LinkedIn if you have a question that you want to specifically ask me.
Okay. CJ, thank you for the time. I really appreciate it.
Thank you.
Absolutely. All right. That's it for this episode. Be back again. Different guest, different topic. Until then, 2 things. 1, I thought this was a fantastic episode. I have covered some autonomous vehicles, but we haven't covered trucking. So now we can say that we've touched on that with CJ. And he actually covered a lot of areas in terms of the process, what's a little bit different from vehicles, things that are challenges for them. We talked about scale and how he views it from the ground up. Also talked about, the regulation side, some of the, bars they have to pass and some of the things that they need to be concerned with getting these trucks on the road, and obviously seems like a great future. And share this episode with somebody else who might benefit from it. I'd really appreciate that. Also, like, subscribe, comment, let me know how the show's going for you. Until next time, thank you and goodbye.